Good morning, dear students. Today we are discuss chapter 2 of physics, that is electrostatic potential and capacitance. So these are the few topics that we have covered in this portion. You have a line integral of electric field. I have discussed in chapter 1, and electric potential difference will be discussed here. Electric potential due to single point charge also cover here. The potential due to group of charge, these few topics, and here area vector, electric flux, these will be already discussed. Gauss theorem, along with the Gauss theorem, along with Coulomb's law of Gauss theorem, these topics covered in our chapter 1. Okay, so we will cover uh, in this slide these two 1 to 5 topics. Okay, right, from equipotential surface I have already covered in chapter 1. Okay, so let's continue with this, right? Okay, so first one is line integral of electric field, that is work done by electric field. First I will tell you that what is potential, electric potential. Okay, so potential means something that will be flow. Okay, it's like that. फॉर एग्जाम्पल अगर मैं ये लाइन इंटीग्रल ऑफ इलेक्ट्रिक फील्ड की बात करता हूँ, ठीक है, फिर इस पे मैं आपको पोटेंशियल का जो डेरिवेशन होगा उस पे बताता हूँ, ठीक है. So that negative line integral of electric field represent the work done. Just wait a while, let me select the laser pointer. Negative line integral of electric field represent the work done by the electric field on a unit positive charge in moving from one point to another point in the electric field. So this will tell you that you have to put some minimum work so that you can move a unit positive charge from one point to another point. Without giving an work, you cannot move a charge from one point to another point. If there is electric field, if there is no electric field, you can easily move a unit charge from one point to another point. This does not require work. Okay, so first thing is what, when you move a unit positive charge from one point to another point, there must be an electric field, so that you have to do some work. Okay, this is what the equation. So what will be our work done? Our work done is, we can consider a small amount of work, that will be dw, which is moving from point A to point B. We have, okay, so it will be E, but that is electric field dot dl. Dl is what? Dl is the distance or that you have to move, right? This may be considered like that. This is x-axis, y-axis, z-axis, and this is positive charge plus q, right? And these are the 2 point, A point and B point. Okay, and RA is the position vector of point A. Similarly, RB is the position vector of point B. Okay, then if you move, let's see again, if you move a charge from A to B, how it will move? It will move like that. You can see that this is a slightly curved path. It means that the motion of charge from A to B is independent of what the path followed. It may be either upper curve, it may be either lower curve, or it may be either a straight line. It does not matter which path you are going to follow. You can take it any of the path as per your choice, right? So this is what Q naught is a test charge, or this may be the direction of force between what it will be test charge as well, and because the nature of test charge and this plus q charge both are positive, so the nature of electrostatic force will be repulsive in nature, so it will be move away from the diagram, right? So this is the position vector of r, that is test charge. And let's see, let q naught be the test charge. In place of unit positive charge, the force F equals to plus q naught E. This is, we already know that the electrostatic force will be the will be what, product of charge and electric field, right? So here the electrostatic force will be what, product of test charge into electric field. Okay, acts on the test charge due to the source charge q, right? It is radially outward and tends to accelerate the test charge. Okay, so this is what this is saying, that because of the nature, same nature, like nature, both are positive, so it is radially outward and try to accelerate. Okay, but the nature, when you shifting A to B, right? Then what happen? Because what we do, we are first creating the electric field here, or when we are going because of the electric field, the force will be applied on this test charge. If there is no electric field, you no need to do any work. Okay, because of the presence of electric field, that's why we do some work done. And the electric field, what electric field is doing, electric field is applying our regular forces, that is electrostatic forces, on this charge, which is you are moving from A to B. To prevent this acceleration, equal opposite forces Q naught E has to be applied on the test charge. Okay, right. So to prevent the acceleration of this test charge, equal and opposite force, that is negative equal and opposite force, that is minus Q naught E, has to apply on the test charge. Okay, so we need to apply this much force so that this will we continue to move from here to here without uh, moving from out of this boundary, so that the total work done by the electric field on the test charge in moving it from A to B in the electric field is will be equal to WAV is equals to integration dW, that is small amount of work from moving A to B. Okay, this is minus, so that we are applying equal and opposite charge, opposite force, which is equals to E dot dl, right? We know that what is the value of E will be product of charges upon 4 pi epsilon naught or 1 by r, right? So we can write this as Q into Q naught 1 upon 4 pi epsilon naught 1 upon RB. RB is the position vector of B, and minus 1 upon RA. RA is the position vector of point A, because we are moving from A to B. So that where we are going, then the point B इस पे हम गए हुए हैं, that will be written first, and from where we are coming, that will be written behind, right? So you can take the screenshot of this, or you can copy this. Next, after this will be become WAB is equals to integration of work done from A to V minus E dot dl, which is equals to product of Q and Q naught upon 4 pi epsilon naught within bracket 1 by RA, that is position vector of B charge, minus 1 upon RA, that is position vector of A charge. Okay. So what is saying, that the equation shows that the work done in moving a test charge Q naught from point A to another point B along any path AB, see here, any path, it means that it is independent of path followed, right? The equation shows that the work done in moving a test charge Q naught from point A to another point B along any path AB is in an electric field due to plus Q charge depends only on what? Depends only on the position of this point. Okay, it is independent of the actual path. It is independent of the path followed. Listen, student, it is independent on what? Path followed, right? So follow between A to B. Okay. What is next conclusion? Next conclusion is that is the line integral of electric field is path independent. Okay, we know that this is line integral is path independent. Third one is, therefore electric field is conservative field. Okay, conservative field, this is electric field here applied is. Third one is, line integral of electric field over a closed path is 0, right? This is another condition satisfied by conservation field. Okay, line integral means the electric, if you integrate the electric field over a closed path, you will get 0, right? Like that. From A to B, close integration E dot dl will be equals to 0. Note, the line integral of an static electric field is independent of the path followed. However, the line integral of field due to moving charge is not dependent of the path because the field varies with time. Okay, go again with this note. Line integral of of only static electric field. Remember the word static. Line integral of only static electric field is independent of path followed. This is path followed se jo independent, this will be written only for the static electric field. However, when the line integral of electric field due to moving charge, when charge is moving, if the charge is static, then it is independent, and if the charge is moving, it is not dependent on the path because of the field varies with time. If charge is moving, then the strength of charge is also changed with time or change with their motion, so it will not depend on with path. Right, you can take screenshot, or I'm moving further. Then going with electric potential, what is it? See, I shifted my screen. Electric potential is a physical quantity which determines the flow of charge from one body to another body. As I told you that electric potential, if you have, I'm giving just a small example. If you go to fill air in your tire of your bicycle or your cycle or your car, then there is a shop of tire, there is a compressor, air compressor, right? And in air compressor, air is at high pressure. Okay, it will be around 100 to 200 psi, like that. So in that compressor, high pressure air, and in your tire there is a air about low pressure, around 20 psi, like that. So the flow of air from compressor to, when he plug the pipe in your tire, the flow of air is from compressor to your tire. It may also happen that your air can move from tire to compressor, but because of the high pressure, it in the what I say, in the cylinder, it can move from cylinder to your tire, because cylinder has high pressure and your tire has low pressure. It means that always the flow is from high to low, not from low to high. This is what general. Okay. Similarly, in case of potential, the flow from high potential to low potential. Okay. When you use appliances or anything in your household, always the flow of electricity from high potential to low potential. It will not flow from low potential to high potential. And it will also continue till the potential become equal, right? So this thing you have to in mind. Electric potential is a physical quantity which determines the flow of charge from one body to another, right? It is a physical quantity that determines the degree of electrification of body. You can also write this. Electric potential at a point in the electric field is defined as the work done in moving without any oscillation a unit positive charge from infinity to that point against the electrostatic force irrespective of the path followed. Okay, so it is what it is, the amount of work done to bring a unit positive charge. Unit positive is as small as one, that is one unit has a positive charge, and it will be taken from infinity to a particular given point irrespective of whatever the path you are going to be followed. Okay, so this will be the formula I have already told you. That is WAB from A to B, E dot DL is equals to product of charges divided by 4 pi epsilon naught 1 by RB minus 1 by RA. The formula is still same, or you can write like that. According to the definition, if RA become the infinity, you have to bring from infinity. So RA become infinity and RB become the R, where R is the distance from the source charge and the point of consideration. So this formula will be written as W from infinity to B upon Q naught is equals to Q divided by 4 pi epsilon naught R, because this term will be become infinity. RA become infinity, the 1 upon infinity becomes 0. So 1 upon RB become 1 by R. So this 1 by R here is 0. So this will combine with this and you will get this formula, right? So this can also written as V equals to W infinity B by Q naught. Okay. SI unit of electric potential is volt or joule per coulomb or Newton meter per coulomb. Right. So this will be covered up to this slide. Rest of the topics I'm continue with next class. Okay. So try to complete this, and whatever the doubt, you can ask me on the group. Thank you. Have a good day.